So we have seen mobility and we have defined it as the average particle drift velocity per unit electric field. So we have said that its equation we can write it as mu equal to, so we have average particle drift velocity. So here it represents average particle drift velocity per unit electric field. So this is our general equation. We said that it's a modulus. Now what is the unit of mobility? That is important to remember, the unit of mobility. It will be helpful to check whether your equations are correct in coming videos. The unit of velocity will be using centimeter per second, and that of electric field will be volt per centimeter. So we will get the unit of mobility as centimeter square per volt second. Now the mobility, we have defined it as the ability of charged particles to move. So it will depend on the conductivity effective mass of the charge carrier. We will use the same notation, that is m star. So it is different from density of states effective mass we have discussed in the earlier video during the derivation of carrier concentration. Here we are dealing with charge transport. So we will be using conductivity effective mass. And it also depends on the scattering probability, or we can say that the mean free time between scattering events. So it also depends on mean free time between scattering events. So we may denote it using T bar. Now we'll discuss about actual relationship between mobility and this effective mass and the probability of scattering when we derive the expression for drift current. Now let's see what happens to mobility with temperature. And we have said that it depends on scattering. We have mainly two types of scattering mechanisms that determines mobility with temperature. Now it is reasonable to assume that mobility decreases when the effect of scattering increases. So mobility decreases with scattering. So there are mainly two scattering events that affects mobility, and they are impurity scattering and lattice scattering. Now among these two, one become dominant at low temperatures and other at high temperatures. So impurity scattering is the dominant event at low temperatures and lattice scattering is the dominant event at high temperatures. Now let's see impurity scattering. So at low temperatures, we can say that the charge carriers will have low thermal velocity. So because of that, the energy of these charge carriers will be less. So the probability that these charge carriers will get deflected or scattered by impurity ions become really high. So at low temperatures, we can say that there will be a reduction in mobility due to impurity scattering. So it's proportional to T power 3 by 2. The mobility decreases with decreasing temperatures at low temperatures due to impurity scattering. Now let's see lattice scattering, and then we will see the comparison between these two. Now lattice scattering, as I mentioned, become dominant at high temperatures. At high temperatures, there will be high lattice vibrations. So we have the particles which have high velocity, high thermal velocity, but the frequency of collisions or frequency of scattering events with the lattice increases with high temperatures. So we can assume that the mobility will decrease at high temperature due to lattice scattering, and it is proportional to, that's the mobility will be proportional to T power minus 3 by 2 due to lattice scattering. The mobility decreases with increasing temperatures at high temperatures due to lattice scattering. So let's see the graph. So at low temperatures, we have impurity scattering which dominates, and there is a decreasing mobility with decreasing temperatures, and it is proportional to T power 3 by 2. And at high temperatures, due to lattice scattering, there is a mobility reduction, and mobility is proportional to T power minus 3 by 2. So these are the two main scattering events that affects mobility. An important point to note here is that if the amount of impurities is really high, that means if we dope semiconductor materials with large number of impurity atoms, the effect of impurity scattering will be visible at higher temperature ranges also. So this is an important point to note. Now in the next video we will see what happens at high electric fields.